Thank you so much, and thank you, Anders. It's really inspirational hearing Anders talking about these things, and I've been thinking a lot about this. So, my title is Captain Kidd and the Mysterious Data Lake. So, and essentially what we're going to talk about is simple things that you can do to prevent piracy. And these pirates are using different technologies, and we're going to get into some of those. I tend to speak about things that anyone can do, no matter on what CDN you are. So everything that I talk about today, you can do with whatever vendor you're using. Yeah, my name is Anders Nessman. I work as a principal solution engineer at Akamai in Stockholm, Sweden. So yeah, that's all for the introduction, I think. Pirate stories, good thing. Captain William Kidd, born 1645 in Scotland. Everyone in this room probably thinks about this big pirate now. But he was not a pirate. He was actually a pirate hunter like Anders. He was what's called a privateer. So he worked for the British Navy and hunted pirate ships. All the way until 1698, when he captured the wrong ship. He took a legal ship and he captured that. Not a good thing. And we get to what happened to him at the end there. A little bit about the story or history. You who are old recognize this logo. It was on SVT, our main channel in Sweden at that time. It was for a pirate program about TV pirates, but that's not really what we're going to touch on here. So TV piracy in Sweden started off with people wanting to watch cable TV. It was primarily electronics engineers, like myself, trying to fiddle with the signal so you can actually watch the video yourself. So all those channels. But you really didn't care about the channels. It was the fun part of actually breaking the DRM, or the DRM of that world. This progressed into the digital world. And in the digital world, you have set-top boxes and you have cam cards, and that kind of works out as a DRM of the streaming service. But people found out that I can place all those cards centrally and place them on a server, and I can have all those set-top boxes connecting to me and fetching those keys and be able to play it. So all of a sudden, you have a kind of central place where you share everything. And in the background here, I asked DALL-E to create me a picture of a routed set-top box. Yeah, well, judge the result yourself. It's, yeah. With this, the scale, because you didn't need to build small boxes anymore, you could scale immensely. So with that came money. And money is a dangerous thing, as we heard. In parallel, a lot of other things happened on the music side of things. We had a compact disc, and on a compact disc, one song takes 55 megabytes roughly in size, and at this point in time, we're talking about 1996 something. Internet was not that fast, it was 56K modems. So downloading 55 megabytes didn't work that well. But MP3 was introduced, and with that came services where you could download all these assets very much simpler. And now the size of these were like 3 to 5 megabytes in size. Very nice and convenient. We build on the same story, and we bring video to the picture. And with H.264, again, video could be downloaded and very much more simple to reuse and repurpose. And right now we're at this stage. We are doing the same thing with live video. So now live video, as Anders alluded to, can be watched, and a lot because DRM is broken. And what are they doing? There's like two ways of doing this. Some of the pirate guys actually, they use legit accounts, so they steal your accounts, and that's another story. We can talk about that at another time. But they steal your accounts, and they use them, and they play media from there. Sometimes they use multiple accounts, and they play the video from there. So they either bring it up to their server and remove the DRM, or they're using their own player, and that player just removes the DRM for you. So very convenient and very nicely packaged, as Anders talked to you about. What I'm going to primarily focus on here is URL sharing, but the methods that we're going to apply here applies to all. So what is that method? We're going to divide it into 3 parts. First part is we block everything that is obvious. Very simple on a CDN. We identify the stuff that is not that obvious. We'll get to that. And then finally we block that stuff as well. Simple process, 3 things to remember. First chapter, block the obvious. I'm working for a CDN, and with all CDNs and all distribution technologies on the internet, we heard a lot about it today, there's an edge. And that's where we have all our service. And there's a lot of stuff that can be done on those edges. And to be fair, I mean, all the pirates are also coming in through those edges. So why not stop them there? Why have them go back somewhere and fetch stuff? We blocked them already at the edge. First of all, there are freely available lists of user agents that should not be on your service. There are outdated user agents. There's, VLC user agents, MPEG user agents. Don't get them in there. There are free lists, again, to fetch and just block them. Then, on your service, only allow content from countries which you should have your service in. Why would you allow your service to be freely available in Japan if you don't have the rights there? VPNs. This is a little bit of a dangerous spot because there are legal VPNs as well. Probably Private Relay is the biggest one, operated by Apple, that everyone almost is using without knowing it. But there are also others like Tor nodes and other VPN solutions. Again, there are lists for those, but there are also services like MaxMind and GeoGuard and others that provide these kind of lists for you, so you can get them from there. Cloud environments. How many of you have users that actually sits on the cloud environment and watches? Block them as well. No reason for them to come in if you don't have tools there that you actually use. And then we get into this, bad networks. I know Anders have identified a few ones, so you could just go and talk to him and you get a few ASNs that you should just immediately block. That's also a simple thing that you do on the edge. And then known bad IPs, again, same story. There are lists on the internet of bad IPs if your CDN can't provide it to you. And again, TLS. When you connect to an edge, you're using SSL, HTTPS, for you who don't know what it is. And in that connection, there is a you can actually derive a fingerprint of different parameters that makes the request pretty unique. There's a standard for this called JA3, but you can also use other TLS fingerprints. So again, just derive that, look for fraudulent ones. You should not have them in your service. And Anders also talked about you had the movie before it was even, real time ended. So you can also apply rate limiting and say, hey, my highest bitrate is 6 megabits. Why would you allow 35 megabits of download of that video? So this is going to make it cumbersome, at least for the pirates. So now to the more interesting part. You should all have done this now, blocked everything that is obvious. Now we get into the hidden things. And to do something in a CDN on the edge, you need to have some kind of way to recognize that this is a stream. Otherwise, if you think about it from an edge, I'm just getting a lot of requests from everyone. And there's like no way to tie this together into play requests. It's just a bunch of requests coming at me all the time. So you need to put an ID there. Otherwise, there's no ways for us to track this or do anything with it. So that's the first thing you do. The other thing you need to do is to put some kind of tamper protection so that people do not change that ID, because they could pretend being someone else, and that's not going to work either. And the third thing is not really something that you need to do, but there is a standard that I think my colleague Villot talked about like 2 years ago here, called CMCD. It's an open standard for communicating a number of parameters in your requests. One thing is the ID, it's the session ID, so use that as well. It's readily available and it's a standard. So I promised to talk about the data lake, and again, I took some help here from DALL-E to create pirates in a data lake. Yeah. This is a log line. They could look different from different CDNs and different vendors. It really doesn't matter. There's a whole bunch of data. This is JSON. It could be a comma separator or whatever. And you see some of these things that we can read, the user agents and so forth, and that's what we can block on. But what's more interesting here is the ID. So we put an ID here called my secret token, and we also put a lock there that we call a token. This can be done with, again, all CDNs. We all use different technologies, and we'll get to a solution to that in a little bit. A very common token type is JWT, for example. So if we take all these log lines, this could be millions of log lines. I mean, if you think about it, every little thing that is fetched to stream something is creating a log line. We put them in a row, and we use this ID. Then we can recreate the session, and we can see, oh, the player is actually playing this stuff. This is HLS. So this is probably on some kind of Apple compatible device or something that is using that protocol. We can see them in time, and we can see that it's using playlists and it's using TS segments. It's probably a pretty old player as well. If you plot them out in time, we can see that this one is pretty straight. I promised to walk around, so I will do that now. So you can see it's a pretty straight line there, around 12 requests per minute. A pretty decent one. And we do the same thing for Dash. You don't need to know too much about Dash, but it's another streaming format. You can see different file types again. For the other one, we had TS segments and playlists. Here is playlists and MP4s. Audio, video, all downloaded. A little bit more of requests here on Dash, so you can see that per minute, we're ending up at like 48-ish. This is going to be really hard to see. I was a little bit afraid of this one. And we're going to see how the next one looks. If you see here, it's kind of consistent color in this graph. And just remember that for now. It's representing the different colors from the different file types. So it's pretty consistent here. Remember that, and we'll see how it looks in the next slide. To be able to work with all this, we need some kind of tool. So I created a small tool on top of the data, the log data. And it consists of a few parts. The upper part is the same graph as you saw before, albeit it looks a bit different, right? This is not how the other playbacks looked. Below that is a table actually showing the different sessions that are reusing this token and this user ID. So we can see there's a lot of reuse. And actually, if you look at the graph, you can also see that, oh, we're way higher than both HLS and Dash on this one. So we're actually, someone is reusing the stream. This is coming from a real service, by the way. In the table below, we're checking the IP. We're checking the user agent. We're checking if it's VPN. We're checking the country, city, ASN. And I'm also plotting how these different players are interacting and reusing segments. So I'm just checking where are they fetched from and at what time. And I also create different colors for these, and you're going to realize why. Then we have some red things here. And they just represent that, oh, these are not the same as the first one. The first one was fetching the first playlist. So we can see that these are different, albeit very similar, but different. Log lines doesn't look at all the same as the others. If you remember, to the right we had one color. But now it's representing all the colors we have in our timing graph there. And also, the media file types, they're not really consequent either. They're just mixed up. So remember the old one, Actually, now I also showed the upper color, which is coming from the timing. And this is how this session looks. It's a total mashup. So you realize that, hey, we can use pretty simple methods to recognize if this is a piracy session or not. If we want to get really fancy, we can go back to our AI libraries and do analysis on it, but we don't really need to do that. This is simple math. We're just checking how many segments are played on a normal session. So what's the architecture? You're thinking, oh, this takes a lot to do this. This is the normal delivery flow for media. You have a viewer, you have the CDN edges, and you have the origin. What we're adding here is the rules. Can apply it to any delivery mechanism on the internet today. Put the rules there, user agent, VPN, all that stuff should sit there as rules that you can change as you need. Then we take the logs, real-time logs available from all CDNs, just look at them, and then place a GUI in front of it. And we saw some good examples on what you can use, for example, Grafana for, but you can also create your own GUI if you want to, like I did. Now to the fun stuff. I'm going to block these guys as well. So, using the ID, remember that one? We can now do a lot of things that we talked about. For example, we can check, because we now know a playback is a playback, and every playback is a playback that we can track. So we can track that, the playback should not be going on for like 12 hours or more, or we can set any boundary we want. We can lock a specific ID to a specific playback, and we can also put a lot of other things from these requests into our tokens and actually lock those to a specific device. So we can be very specific when it comes to locking mechanisms here. I'm just going to see that I'm not missing anything I want to tell you. No. Good. So IDs are there, and I thought maybe a small example. Now it's going to get excited. I talked to Anders before, and he said the video is going to work. So I'm just going to do this. Yeah, it works. Good. So I have a node script where I generate the token, and up on the top I have a player. Normal web player is a normal, you can visit it if you want to. Nothing to see, it's just an HLS.js player. So I just take that URL with the token and the ID, and I put it in there, and I start playing, and you will recognize a small bunny in the soon. Then you have a green bar there, and that green bar is actually checking if I can fetch the segments in the background. Now I also blocked the token, or the user, and now I'm going to test the access. So now I'm essentially just going to take that link and I'm going to request it over and over again. So it's essentially running curl and just checking for the response code coming back. This will now take a little while, so I took the liberty of jumping forward a bit in time. You missed a bit of the bunny. Yeah, you can see it's still playing, but now I got a 403. 403 means it's blocked. I can't read it as a browser. But it's a little bit weird, right? The video is still playing. This is because it's a VOD and it's buffered, so it has 3 segments in its buffer right now. For live, you can actually bring this down, and also for VOD, you can bring this down to be shorter if you want to. And now you see it's finally timed out and everything is locked. So now, with those tools at hand, just small scripts to integrate with my CDN, I can amend my UI. So now, with my UI, I have a top list of the most shared tokens. It could be user IDs. I put tokens here. And the count of how many, and this is again from a normal service, we see up to hundreds of shared per account or per user. So it's pretty amazing numbers that you see. But what we can do now is we can also block, and I put a green button there, and that's for Nordic Content Protection. That's, you can download the session as well, so you get the logs downloaded to you, and you can use that for forensic work. So back to our architecture. You have the rules, you have the logs, we have all the things. The only thing we're adding now is kind of a line back so that we can also send blocking and other rules into our rules database there. Also, could be interesting to know, do you need to have massive amounts of resources available to you to do this? No, not really. I tested this with log files coming in at 350 megabits per second. We see services that have log files of like 13 gigs per second as well. But this example was built for 350 megabits per second, 75,000 requests per second essentially coming to the CDN. And the second thing I'm doing here is just normalization. If you have multiple CDNs, you need to normalize the data because it will look different. So you do that before you pour it into a database, where you keep whatever time you want. If you want to keep your logs forever, yeah, just pay a cloud provider and you're happy. I put 12 hours in because I could squeeze that into almost a memory. And then a user interface on top. I built it in Node on Kubernetes, but again, you can build it on anything you want, or you can just run reports in Kibana if you want to in Elasticsearch. And then a return path where we block stuff. But you may come to the conclusion that this is very complex because I'm doing in-stream switching with 5 different CDNs. There is a resolution to this. There is a standard coming out, the Common Access Token. It's still in work, so when you photo this, you will get to a page which is the draft. The draft is built by CTA Wave, and they're also the guys that are behind CMCD. So hopefully this will become a widely spread standard that everyone will support. Otherwise, most CDNs today also supports edge compute, so you can actually read these tokens in whatever CDN you have, as long as you have some kind of edge compute capability. And that's also a way you can do with other tokens. As long as you know how the token is constructed, you can use your edge compute to unlock that content. So the epilogue, and actually how I started this as well, is, I mean, hey, just go do this. It's not that hard. It will take you a few hours. But I mean, collaborate. This is not something that you're competing with. This is something that we just want to block and get rid of. And the more people get acquainted to using real services, the better it's going to be. So back to our poor Captain Kidd. 1698, his career was over. He captured the wrong ship. In 1701, he was hanged outside London. And for our 21st century pirates, I don't hope that they will be killed. I hope they will survive, but not in that. Maybe they can do something better with their code. Maybe they can do better things. So what we successfully did over the last 23 point something minutes was to block the obvious. Just get rid of those user agents, those VPNs, those easy things. Just block it. And then try to identify the hidden. Again, work that we can do together. Consult with your colleagues, consult with others. Here's a full room at the next fika where you can discuss these things with your competition even. And then block those hidden ones as well. I think it just all makes sense. So with that, thank you. Happy hacking. Go do this now.